3.4, we're solving equations now. Exponential equations, logarithmic equations. Here are some strategies for solving it. We've already looked at what I call one-to-one, where if you can get the two sides of the equation to look the same, you can just set things equal to each other. Step 2 would be write, the exponential and logarithmic forms. So that just means switch forms. And basically 3 is the same thing. Equation round your answer to 3 decimal places. So, part A here, 1A. The first rule of working with exponential functions, because our variable is stuck in the exponent, I have to get at that exponent somehow. You need the base to be all by itself. So the very first thing you should look at is trying to get that base all by itself. So if I divide everything by 4, now there are 2 thought processes when you do this. And I'll show them both and then we'll just maybe have to pick one way. Or I tend to take a logarithm on both sides of the equation to bring exponents down in front. Because that's one of the properties. If you take the logarithm of a base, you can bring its exponent down in front. Now what base is that exponential? Base E. So what logarithm do you think I should do? Base E logarithm, right? Which is the ln. So I'm going to ln both sides. The 2x then can come down in front. The reason why I choose the logarithm base of the exponential base is what happens when you do the ln of E. What's the ln of E? 1. They're inverse of each other, right?
Yeah.
So it really is 2x times 1, which is just 2x. So typically, when we do these problems, if you pick the same logarithm base as your exponential base, we're going to skip all those steps and just write that. How do you solve that?
ln of 4.
Divide by 2. So x equals the ln of 2 divided by 4. It says to approximate it. Oh, I wrote it wrong. You'd think it's Monday, right? So, 4, close it, divided by 2. The most common error is that you guys forget to close that second, so it's 0.6931. I have the exact answer written down, and I have a decimal approximation written down. The decimal approximation, because when you talk about 0.639, 931, that's just kind of a arbitrary number to most of us. You could actually take that now and plug it in here. So carry it out to 4 decimal places. 4. 2 times 0.6931. Take e to that power and then multiply by 4 and you can get 16, right? So let's try that. It was 2 times 0.6931. So I got that again. So second ln gives me the e and it can raise it. I can go second negative. So I'll take the last answer, plug it in, times the 4 that's out front. Now, why didn't I get exactly 16?
Because you use all the decimal answers.
Because my decimal answer is a rounded answer, right?
Yeah.
Okay, but I know I got the answer right. Here's what I was talking about, the kind of the second school of thought on these problems. So go back to the red stuff. We had E to the 2x is equal to 4. Now you don't have to write this down, you can just watch and then say, I don't want to do that. I tend to use a logarithm and bring the exponent down front. Some teachers will say, well, this is an exponential. What happens when you write it in log form? Log base e, right? Well, what's log base e? ln. So some teachers say, oh, well, that's the ln. Logarithms are always equal to the exponent. They got to the exact same thing, right? I apply a logarithm on both sides to bring the exponent down in front. Or you can think of it, it's in exponential form, right, in log form, and you're at the same spot. Okay? So I don't know what your Algebra 2 teacher taught you when you're doing this stuff. And they may have picked one or the other. But it's really the same thing. Because then you just divide by 2 on both sides. Okay? But the key will be get the base by itself. Get it in base or get it into exponential form. That's what you're going for. What are we going to do here? Again, we have this e is a base, and the exponent contains my variable that we're solving for. So I heard a lot of people say add the 8. So let's add the 8 on both sides. Then what? We got to get rid of the 5 so that the base is all by itself. You can go to the decimal for that if you want. I'm just going to keep it 22/5. Now what? We can pick a logarithm on both sides again. My suggestion is that you pick the ln because that's base e logarithm. You can, if you want, do a base 10. You can do a base 3. You can do a base 7 if you like. I don't really, you know what? Sorry. So, let's just ln it. That allows the exponents to come down in front. So I have x plus 2. There's more than one thing in the exponent, put it in parentheses. What's the ln of e? Let's get in the habit of doing it the right way. The x plus 2 comes down in front. What'd you say the ln of e was? 1. So when I bring the exponent down in front and I multiply times 1, I just have x plus 2, right? So that is the inverse property. You are literally applying the inverse property. Now what do you do? Subtract 2. So my answer is the natural log of 22/5 minus 2. Natural log of 22/5, close it. You get that, minus 2, you get that. So what is it? Negative 51/84. 51/84, right? Exact approximation.